Hey all, it's Altbeer here, and streaming the badge building session. So this is our design session for the future badge, and so you should be able to see me on Twitch for those of you on the audio link. And I don't know if the Twitch people will hear you on audio, so I'll try to repeat what you say if there's questions. But right now there's no viewers on Twitch, so no problem. Today I want to start looking at the electronics. So we already have a concept, and let me know if you guys are having issues seeing what I'm sharing on the stream. But the concept is going to require quite a few LEDs. So I'm thinking anywhere between 4 and 6 of the NeoPixel type programmable LEDs, and then anywhere between 10 and 15 of the normal LEDs. So the combination of that will give us the effects we want, I think. Now, to drive that, we have some decisions that we need to make. We're going to need to decide what kind of MCU we want to use for this. If we want to go with like an ESP or the Pico like I used last year, or something else. We also have to figure out power. And so I figured on this stream, I would just start a rough schematic. All right, let's get this thing open. All right, so as far as LEDs go, I guess we'll just start with the minimum and build out from there. So let us add some items. And I was searching around because I am using KiCad 6 for this. All my previous builds I've used 5. I haven't used 6 too much, so just getting to learn the tool as well. All right, so let's get a battery, or no, LED, that's what we're going to do. So here's a NeoPixel LED. How do I zoom? No, that's up and down. That's left and right. Where the hell's the zoom in and out? Okay, that's annoying. I'm gonna have to look up the keyboard shortcuts. All right, so here's our NeoPixel. This is going to be the same type of NeoPixel that I've used in the past. It's a through-hole one, so it has 4 pins, and it's a 5mm housing. And the 5mm should fit in between the 2 PCBs that we're planning. So let's get like 4 of them out here, and we can move them around later. Okay, and then for regular LEDs, I was thinking of going with 5mm as well, since these have to be 5. I haven't found any 3s out there. So let's add one of those. Okay, where is LED 5mm? Here we go. Actually, can I wonder if the copy paste works? Yay, that's quicker. So there's 5, 10 of those. Okay. All right, so we got our 4 NeoPixels and 10 regular LEDs. That's our bare minimum. Now we got to choose what controller we want to wire this thing up to. So thoughts from the badge building team on the audio. What do you guys think? Who has experience with what? What should we be looking at? not hearing you guys. Are you hearing me?
Oh, yeah, I'm here. I'm hearing you. I
Okay.
do not have experience. I'm just kind of here for moral support at the time.
All right. And I think that's Sapien on as well. You have a
Yeah.
preference?
Yeah, sorry, I finally got the audio working.
All right.
I like the ESP32s. That those Arduino compatible boards.
Hmm.
I like them. They're pretty good. I remember we were trying to figure out which one had the most pins. That was kind of the last time we are looking at that.
Yeah, but I don't think we need as many pins this time as what we were talking about when we were discussing doing all the 7 segment displays. That was a ton of pins needed.
True.
So, like a 8266 might work, right?
Yeah. Yeah, I definitely I like those two the most, just because they tend to have the Wi-Fi. They tend to have
Yeah.
kind of the full range of things that you want to use.
Yeah, I'm thinking we might be able to get the 8266s cheaper than the 32s.
I think that
Those would be the ESP chips with the Wi-Fi. Like I believe I was telling you at we were talking about it at DC214.
Hmm.
Um, you can set up like a web GUI type thing for people to like manually set their own how they want their lights to look at a particular time as well, which would be
Yeah, yeah, and I think we
relatively
can do that with either of the
simple.
ESPs. Do like a web GUI or something like that if we wanted to get fancy with how to program it, right? Um, so I say we start with like the 8266, which I think the 12F is a version of that that's a form factor of the 8266. So, or is that just the RF? I thought it was both. Let me see.
I think the 12F. I think that's one of the ones I have. I
Yeah,
think
that's
that's like
got
the
it's
Node
got the
MCU
Wi-Fi
one.
built into it, but it's got the
Not the Node
ESP.
MCU. The
Yeah,
D1 Mini.
yeah, I'm pretty sure I have one around here. Yeah, yeah, yeah.
Let me check.
Yeah,
I got
this
them
one's
scattered
this
as
one's on
well.
a dev board. This one's on a dev board, but it's a 12F, and yeah, it's got the ESP and the Wi-Fi all built together. So that will probably work for us. So, and we'll just have to see if there's enough GPIO. If not, then we can take a look at one of the other ones. All right, so we'll start with this guy as a placeholder to see if that's going to work for us. Then we have the capacitive touch as well, because if you remember, we're going to have the top board with the DeLorean. He's going to have a bunch of touch panels on it, and we want it to be programmable to do stuff when you touch it. So I know I don't think the ESPs have any kind of built-in capacitive touch circuitry, so we'll have to build in that circuit here. I don't think that's that complex. I think I've done it before. Yeah, now that I think of it, when I did the Godzilla versus Blade Runner badge, that one I used a trinket that had built-in capacitive touch. So yeah, I've played with those circuits before, though. So let's save that. We won't deal with that tonight. But yeah, we'll have to put capacitive touch. We'll have to just make sure we're reserving a pin for it, and then I'll figure that out. All right. So if we want to make the best use of the pins on this guy, and knowing how we want this thing to light up. So let me go back to the concept drawing here. So we're going to want in this flame area here, this is going to be kind of see-through on the first board, and the LEDs will be shining through from behind. We're going to want at least one neopixel over here and one over there, and then several like red or orange LEDs for the flames, regular ones. Now what I'm thinking is we can pair these up. to share like two regular LEDs on a GPIO. And then if we interlace them, it won't look like they're shared because you'll have different ones going on and off, like intermixed. So we can like have an effect where we're bringing these three on and these three on later and back and forth. That way it saves the GPIO pins and any kind of, if we're doing, I don't know if we're going to do PWM on those or not, but it'll save us work of having to program all of these individually, where we can just kind of pair some up and space them out on the board to make that work. So that's one. So that's like two, and we'll call it 1, 2, 3, 4, 5, 6. Yeah. So that's, yeah, I can see right now we're going to need a lot more LEDs. So let's call these two and these 6. There's our flame. Now we have our lightning, and the lightning was going to be the same thing. It's going to be kind of see-through on the first board. The board below it will have the LEDs. We're going to want at least 2 NeoPixel to do like flashing effects with other colors, and then probably 6 regular LEDs that are either blue or white, maybe 3 of each. That way we can pulse those on and off and give it a nice lightning effect. All right, so this will be the lightning then. These 2, these 4, 6. Okay, so that takes care of the flames and the lightning. And then we were going to have a couple of other regular LEDs spaced throughout here. Like I'm going to draw a clock tower in here. We're going to want one LED to light up the clock. And then we talked about a couple inside the dash. So maybe, I guess we can get by with 1. So let's just call it 2 more regular LEDs, one for the dash and one for the clock for now. So yeah, that's 2, 4, 6. So we get 12, 13, 14 regular LEDs and 4 NeoPixels. Now the NeoPixels we can drive with 1 GPIO. So that's not a problem. We can just chain them together. But for these, even if we're pairing them up, 1, 2, 3, 4, 5, 6, I need 7 GPIOs for that. So how many do we have here? 1, 2, 3, 4, 5, 6. Yeah, we should have enough. Even if we had to add some more regular LEDs, we should have enough. All right, so now we have our basic LED count and an MCU decision that's tentative. We're going to need to power this thing. Now the ESPs, if my memory serves correct, are not able to take in 5 volts. They are very picky about having their 3.3 volt, and it's probably, we should probably look at what it's plus or minus, so we know what the actual top end is to damage. Like, is that 3.7?
When I was playing with mine, I read online that you can get it up to 5, but it's, not necessarily, like, it's not just gonna die on you, but prefers the 3.3.
Yeah, what I don't want to get into a situation on is us guessing that we can drive it close to 5 without damage, and then we buy a bunch of cheap ones from AliExpress, and we find out that the cheap ones actually burn out at 3.7 volts. So that 3.7 volt battery that we're buying is not going to work, right? That's what we need to think about. So if that's the case, we need to step down the voltage of our battery to meet the requirements. So I think one of the to-dos for the badge building team is going to be to research the ESP 8266 and specifically this like 12E or 12F form factor, just to see what the document says are ranges for input voltage on the VCC which is where right here, yeah. So we need on the VCC pin, what is the range that we can use for the input voltage? Because that'll determine what we have to do as far as adjusting that voltage into this pin from whatever battery source we're going to use.
That makes sense.
Okay. Cool. So assuming that we're going to have to step down the voltage, I was doing some research on different ways that we could do that. Obviously, we can get a voltage regulator that's like its own chip, right? That they sell them as like a circuit on a chip, but those are more expensive than what I think we need, which is just a voltage regulation transistor. So the key with using a transistor for doing our voltage regulation is the cutoff of where it's going to stop providing input. So as an example, some transistors they'll have a cutoff of like 4.5 volts, right? And that's if it's supplying a 3.3 volt to the external side, to the VCC. Well, that doesn't work very good if you're using a battery pack that starts at 4.5 volts and goes down as it starts to die, right? So like 3 AAAs, that's not going to work. So if we're using a 3.7, that's really not going to work, like a LiPo. So we have to look for low cutoff voltage transistors. And that's what we're going to have to start researching as well. That's our second to do out of this session. So our first to do is get some documentation on what is the input voltage for the ESP, what's that range. And then we're going to have to do some research to figure out what voltage regulation transistor can work for us for that. Because then that can make sure it's giving the voltage in the range that he wants, but it still lets us use whatever battery we want, right?
Yeah.
And I'm trying to see if I can find where I did some of that research. Yeah, I think one of the things I was looking at was an HT7333. That was one that I actually, let me see if I can open this web page up. Come on. Yeah, I found a few on Amazon, and I ordered these, and hopefully we'll get them in to test them. But these 7333s, they'll step down the voltage to 3.3 volts, and they have a low cutoff, so it's not going to cut off too soon. But the question is, because the input voltage is from 2.3 to 6, is that a steady 3.3 volts out, or is it variable? And I haven't researched this deeply enough to know. So that's why I just grabbed some, and I figured I'd play with them and just do some tests with a battery pack or two and different ones and see what is the voltage it's providing. Is it steady 3.3 volt and then it'll just cut out when the battery dies? Or is it a range? Like, is it going to start at like 3.6 and steadily go down to like 2.9 or something? I don't know. So that's the type of research we need to do, is just look up these different types of transistors. And this is just one of a dozen different transistor types out there I found that can do what we need, potentially. We just have to find the one that's going to work for the batteries that we want to use. And speaking of batteries, I think I've had really good luck in the past sticking with alkaline batteries, like 3 AAAs or 3 AAs, to provide 4.5 volt top end, and then that goes down as the batteries start to die. But that
Right.
that gives us a good way to deal with batteries, because I really don't like lipos, because then if you want to be kind to your badge users, you have to build in a charge circuit so they can recharge their lipo battery on the badge, right? You don't want them to have to disassemble the battery and put it on some external unit we're not giving them to charge their battery. And then shipping lipos is a pain in the ass, especially if anyone's flying to Vegas. I mean, you don't want to be flying with 300 lipo batteries. That's not going to work for most airlines. So with alkaline batteries like the AA's, AAA's, it's no big deal. I actually last year going to Vegas with last year's badge, it was AAA batteries, and I had each box of batteries held like 400 batteries, and I had, I think, 25 boxes, and I took all of that in a carry-on bag through TSA, and they were just like, "That's a lot of batteries." I'm like, "They're all alkaline. There's no lipos here," and they're like, "All right, you're good to go." So yeah,
That's
no,
fine.
no problem with the airlines with alkaline batteries. So that's a big plus. All right, so we have. Is one of you taking notes? Because otherwise, I need to start taking notes. So we need 8266 data sheet for input voltage, and we need a transistor for voltage reg. All right, so I'm not even going to draw the transistor in on here because we don't know which one we're going to use yet, but we know we're going to need something for voltage reg. So let me just put some text here. Okay. All right, so next we have these LEDs, the NeoPixel ones. These I'm using the same ones that I used on the Corsage badge, the homecoming badge that I did. And the reason is I have a relationship with that supplier now in China, and they just happen to reach out to me and say, "Hey, we have 2,000 of these that will cut you a good deal on if you're willing to buy them now." And so I went ahead and bought them now. And so we have 2,000 that should be here end of May.
Wow, nice.
Yep.
That's
Yeah,
a
I think,
lot too.
yeah, I think he gave me like 30% off what I paid for them for the other badge. So it was a good deal.
Yeah, that's awesome, actually.
Yep. So we know we're going to use that same type of LED. And then we have these LEDs. Those are a dime a hundred, not even a dime a dozen, right? These are just little 5mm 2-pin LEDs. So I'm not worried about getting those on order because we can get those from anywhere. The key will be with all of these LEDs, the power. So the little LEDs, I'm not worried about the power because they're getting it right from the GPIO, right? But these guys, we're going to have to power them outside of power in the MCU. So basically, where the MCU is sending its signal for the data in, data out chain, the MCU is not going to power these. So we're going to have to build in, when we start working this power circuit, making sure that these four get powered outside of this and separate from that, because they can, based on how they're like what colors they're lighting and how quickly they're changing, these guys, each one of these can pull as much power as like 6 of these. So we have to be careful in how we wire up that power, because I have, in playing with those, seen where it can be detrimental to it. Like, once again, going back to the Godzilla versus Blade Runner badges, I didn't use these. I used a similar one called an APA 106, I think. And those, because I didn't wire them in properly with the power, if you were to wire them all up to, or program them all up to do white at the same time, they would all dim and eventually just brown out the badge. It was bad. And because it was a hardware thing, there was no software fix for it other than to put warning in the comments, do not do this. And I think I limited the, in the software, I limited the brightness to like 50% on those. But anyone could have changed that and caused a little brown out of the badge. So I don't want that situation with this. We'll make sure that we have the power properly wired in, and that means we will need capacitors in the circuit, because when they draw a lot, you want to give it a nice sized capacitor. I found to take that little extra bit of juice that it needs for that second that it's powering up a lot of light. So I typically put a larger capacitor, because I think they require like a 10 UF capacitor on each of these, and I think I usually go with like a 200 or a 400 UF when I build these, just to give it a little more buffer for when they're doing that transition between colors. It seems to help.
That's cool.
Yeah. So that's another note. Capacitors will not going to draw it in because I'm not sure what we're going to use for that yet. And then, so another design choice that I'm making with this badge this year is I'm not going to throw a USB on there. Just because the USB, one thing I found is you can use it to program, and you could also use it to power. And if we're going to do the ESP, which is what I thought we were leaning towards, I don't want to have to deal with making the USB just program or just power or one or the other. And honestly, there's no good through-hole USB connectors that I've found. They're all surface mount. And if we want this to be easy for people to put together as a kit, I want it to be all through-hole components. And yes, I know this is not a through-hole either, but I have some ideas around that, because you can make it. It does have pins to make it a through-hole, but I've never used those 2mm headers before. I've always used the 2.54. So if we can source the 2mm headers, then that would work for that. But what that means is, to program these, we're going to need to expose the serial programming ports to external test pins that we can easily clip to the test pins with either like an FTDI USB cable or another Arduino or something like that, to actually push firmware to it. And yes, we can have it, like you said, with the we can do something over the Wi-Fi to allow people to upload changes to the code or do different things with the badges. But for that initial flash, at least, we're going to want some test pins to flash the firmware on there. So that's something that we'll need to get on here. So where's my text? Down here. And I may change my mind about this moving forward, because I I do like to make it convenient for users to be able to reprogram these things.
I agree.
But at the same time, I don't want to be dealing with a bunch of surface mount components that nobody can put together. And then they have kits that they can't use because they can't put this surface mount on there. So I'll think on that, but for right now I'm thinking just test pins to flash, it'll work. All right. Well, let me check the Twitch stream. I don't. Oh, it looks like we have 4 viewers. It's probably all you guys on the phone, right? Yeah, there's no chat coming in from Twitch, so nothing to answer there. Shoot. All right, so we have the 2 on that. Let me write down the other to do is capacitor choice for the NeoPixels, and then test pin for flash or USB port. We'll call that a decision yet to be made, either a USB port or test pins for flashing. If we do a USB port, I think my preference would to not have it power, to just like not even use those power pins and just have it use it for flashing the badge. Yeah, I'll have to think on that. All right, so what else? What am I missing? Go back to this. So we have our LEDs lighting up here. As far as circuit stuff goes, I think that covers... Oh, battery choice. That was the other thing we needed to discuss. Are you guys okay with the 3 AAAs?
I mean, it sounds good to me. I'd say 4 max.
Yeah, 3 AAAs. It's like 4.5 is its top end, and I think it'll cut off at like 3.1 or 3.2, something like that. That's when it's dead. So I think that'll work because that's worked for everything else I've used so far. Yeah, the LiPos are just such a pain in the ass. And the reason I'm on the fence about this is I've been seeing LiPo batteries really cheap. And it makes me want to dive into that area because, I mean, the AAA battery connector, just the piece of plastic with 2 pins on it to stick into the back of the badge, those are almost the same cost now because the cost on those is going up for some reason. The cost of LiPos is coming down for some reason. It's like the cost for just the battery holder is almost as much as a 3.7 volt LiPo. So that's why I'm like on the fence. But LiPo is such a pain in the ass. I just don't know if it's worth it. All right. What else? So we got battery. We got... let me put USB choice. Okay. Capacitors. All right. So now let's divvy up some of this to-do work for the next coming week. Who wants to take on the research on the 8266 input voltages? Maybe get us a data sheet on that. That gives us some good info. All right, so you'll take that one on. Sapien? All right, cool. I'll deal with the transistors for the voltage regulation because I already started that. And then as far as the USB choice, I guess what I would want one of you to do is just research what USB connectors are out there that might be easy for people to hand solder, even if it's a surface mount. Because the ones I've used in the past, the pins are so close together, it's just not doable for a new a new person to soldering. But if there's something out there, like a form factor for a USB connector that has pins separated out enough on the footprint that you think it might be easier for someone to hand solder it, I'd be willing to look at that as an option. So who wants to take that on? It's just purely Google research.
I can do that. It's just like a regular USB, like a
Yeah,
that you
just
plug into the side of.
yeah, USB connectors, right? So yeah, if let's see, USB connector, and then we'll call it SMB. So you got all these different types of USB connectors. We just need to find one that is going to have that we're going to have an easy time soldering. So if you jump on like Mouser or DigiKey, you'll be able to download the data sheets for them, and those data sheets will give you what the footprints look like. And just do some research and see if you find one that looks like it's pretty easy to solder. Because the ones that I've been using, they have a whole bunch of little pins. I think it's 5 or 6 pins that are footprinted on the surface of the board that are so close together. People that are trying to hand solder it, if they're new to soldering, it's just impossible for them. They'll bridge it and ruin it. And so that's what I'm trying to avoid, to try to make it easier for someone to hand solder. If there's one of these connectors that has a footprint that's spread out enough that it would allow for easier hand soldering. So if you want to do some research on that, that'd be cool.
Sounds good.
All right. Well, I think that about wraps us for tonight. So we didn't go the full hour, but this is going to be a recurring meeting. So for those, if there's anyone that's going to watch this later on YouTube, or maybe one of my 4 viewers is not on the badge team, basically this is going to be a weekly series, and it's going to be like our badge life diaries of how we build the future badge. So this is the future badge building will happen little by little in this, and we're still in early stages yet, as you can see. But as we get things more fleshed out, hopefully this will be more interesting for people to join and check us out. All right, well, I think that's it for tonight. So I'm going to go ahead and wrap this stream.
Thanks, Albert.
Yep, let me know if you guys have any questions. Otherwise, for those on the badge team, we'll chat in Discord, and we'll follow up on these to-do items.
Cool.
All right, thanks all.
Good.
See ya.
Yep. See you.